Okay, it's 10, so welcome. I was just asked to give this talk in English. I hope this is okay for everybody. I'm not prepared for this, so I apologize for my English in advance and hope you understand what I have to tell you today. So this talk is about TDD and the problems many developers face when they start to try to develop in a test-driven way. My name is Christian Fischer. I'm a software engineering coach, so this means I help to improve the software development process in collaboration with teams. And TDD is, of course, a main method practice for these teams to improve their product quality and also their development speed. So first, I'm interested in who of you is familiar with what TDD is and also tried to do this in a coding dojo, coding retreat? Okay, thank you. And who is developing every day in a test-driven development way? Okay, there are just a few who are familiar with TDD, who are doing this on a day-on-day basis. So this is also my experience. So I'm doing a lot of introduction courses for TDD with teams, and they're highly motivated at the end of these courses and promise, yes, next Monday we will start doing TDD in our project. And when I meet them again a couple of months later and I ask, what are your experience? How does it go with your TDD approach? I'm always hearing some complaints about TDD. There are problems which they didn't expect, and what I hear is that they say, okay, we left this way, TDD works in your coding dojos, coding retreats with the small cutters. But in a real world scenario, in a project, this doesn't work. And when I ask what are the problems, I recognize a kind of pattern. For me, there are 5 major problems when you start with TDD, because the TDD looks very simple, but it's hard to master TDD. It's something like riding a bicycle. It sounds very simple, yeah, and looks very easy, but if you try to start riding a bike, it takes a couple of days. And TDD, from my experience, takes a couple of months really to master and to practice it in a project. And what I would like to show you is what are these problems, these major problems, and how you can avoid them. But first of all, I just want to recap what TDD is, just to make sure that we have the same understanding. So what is TDD in a nutshell? So what we are doing, it's a process. We have 3 steps in this process, and we always start to write a test first. So we are specifying the behavior of the software we would like to implement. This is the test. And the test is red because we don't have an implementation which fulfills this expected behavior. So after we have written this test, the next step is writing the implementation code. And you can do it in every way you like. The idea is that you find the fastest path to get back into the green zone, into a working state of your software. So copy-paste is allowed. Everything you would normally don't do, this is allowed in this phase. You are just focusing on implementing the behavior. And then, in the last step, the refactoring phase, you're focusing on design. So you recognize patterns, code applications, etc. in your code, and refactor the code so that it's readable, maintainable, and extendable. And you're doing this cycle again and again, and it takes a couple of minutes, from 5 to 10 minutes usually. And this is hard to learn, so we are not used to work in so quick steps and in so small steps, these baby steps. This is something you have to train. And this sounds very simple and looks very simple, but as I already mentioned, it's hard to master. And there are some problems arising from this process. And the first one has to do with the last phase, with the refactoring. So the refactoring drives your design, the design of your software. So the design evolution is one of the most eminent problems when you start with TDD. And the complaint about this is every time, so I'm not doing much upfront design when I'm doing TDD. I try to figure out the best design when I look at the code in the refactoring phase. So this means the design is evolving. And the complaint is, when the design evolves, I already have to reconfigure or refactor my tests also. And this takes a lot of time. This is annoying. So just to make this clear, I have a little example. So this is a test for a module in the search engine of an online shop. This is a music shop, and the responsibility of this module is to take the query from the user interface, the query from the customer, and pass this query in a list of words, which then can be passed to the search engine module. And as you can see in the test, the first behavior is quite simple, so it takes a string and returns a list of strings. So the first test case is something with just a single word, and the second one is with 3 words. And the token is for this decomposition is the white space. So you're writing the test first, and then you write the implementation. That's quite simple. And then you go ahead with the next behavior. So in this case, the next behavior is that the so-called stop words are removed from the list. So in this case, stop words are words like with and, which are not required for the search query. And you're implementing this, and then in the refactoring phase, you see, that the parse method has a lot of lines of code. So you decide to refactor this, and extract a private method, remove stop words, and go ahead with the next feature. So the next feature is, for example, that you would like to remove numbers, if there are any numbers in the query string. And again, you're implementing this, and again, you're refactoring this into a private method, remove number. Now, when you look at this query parser class, you see, okay, the responsibility for this class is quite large now. And you see that the remove stop words and remove numbers look very similar, and they are just filter functions. So you decide to do a refactoring and extract the filtering logic from this class, and then you end up with this design. You now have a separate query filter class, and this do all the filtering, and this is passed into the query parser, and the query parser uses the query filter. So what does this mean for our tests? So first of all, we remove the filter-related tests from the query parser test class, and we have to set up the mocks, and we also have to write a test which makes sure that the query filter is called correctly. And these filter-related tests are now in the query filter test, which calls the query filter, and they also have to adjust it because the signature from the query filter is different from the query parser. Means a lot of work. So just by doing this refactoring. And this goes ahead if we go ahead with the next features. So, for example, that we would like to have just lowercase words. And again, when we have the behavior that we would like only have singular words in our list. So again, we are now ending up with the query parser class, which has now some code about normalizing the words, and we also extract this into a query normalizer class, and again we have to adjust the test. And this looks a little bit weird, right? Because refactoring means you're changing the structure of your code. And the tests specify the behavior of the code. So why do I have to change my tests if I'm just changing the structure of the code? This means a lot of work and doesn't sound reasonable. And the problem here is very obvious if you look at the dependencies between the classes. So you can see that there's a one-to-one assignment and dependency between the test classes and the implementation classes. And if we understand our test as a module, a software module, and the parser module as a separate module, this is something you wouldn't do if this is a normal relationship between two software modules. This is a very strong coupling. Especially the both query filter tests and query normalizer tests, they are testing package private classes. So this is the reason why you're doing all this refactoring of your test classes. You have a one-to-one assignment between your implementation class and your test class. This is not what you really would like to have. What you would like to have is such a dependency. So you are still testing the filter tests and also the normalizer test cases. But you are doing this via the public API of the module. And the public API of the module is the parse method in the query parser class. And so when you're doing this, you are free to refactor the classes in your parser module without adjusting your test classes. So you are free to change the design pattern, for example, for this. You can use pipes or anything you would like without touching your tests. So my advice for this problem is develop your test against the module of the API. The API of the module, this way. So I know there are a lot of frameworks out there which create for every and each class, they create a test class. For example, Angular does this. This is not a very usable pattern. So try to find out the borders of your modules, try to find out what is the API of the module, and then develop your test against this API. So you get very stable tests. So we come to the next problem field, the problem topic. The leaky refactoring. What does this mean? So I have a couple of code snippets. So the problem here is that this is also related to refactoring. So if I'm doing something in my class internally, I also have to refactor my tests. So where's the problem? So for example, here this is a code snippet from a project. I worked with a couple of months ago. So this is the setup method for the tests, and they would like to test the item service. I don't know why they're using SPI, but whereas they are using a library from PowerMock, Whitebox, and they are fiddling with the internal structure and the internal member variables of this class. They are setting here or injecting mocks by reflection. So this is a bad code smile. So if I'm just changing, for example, the naming of these fields, these private fields, which I'm allowed, yeah, this is why they are private, I will break the tests. So I know a lot of things about the internal structure. So this is not a good design. So why? I'm guessing that the developer who developed this knew that this is not good. Why did he do this? He did this because it was he needed this class in a very specific state or with very specific collaborators. And if you have such a requirement, my advice is use something like a builder. Yeah? A builder which belongs to the implementation package, and use this builder, for example, to inject a mock or to set the state for the subject under test. So another refactoring which is not so obvious, which also have an impact on your tests, is a test here where you are testing a repository. So this is a class which handles all the SQL queries to the database, and what is so the test is that you are requesting a user by ID from this repository, and the check is against the name of the user. And this is an integration test, and there's a very helpful tool, DBUnit, which helps you to set up your database with test data so that you can run your test. Helps you with the test fixture. And this DBUnit library is a JUnit rule, and it has this very handy annotation, so you can define a YML YAML file where the dataset is defined, which is injected into the database for the test fixture. And this looks something like this. The first view says that why is there a problem with this test fixture? Why is it a leaky abstraction? So let's say we develop our code and we decide to separate the fields in the database so that I don't have just one name field, that I have two fields for the first name and the surname. This means I have to change my test fixture, but this has nothing to do with my test, so why should I change my test fixture just because some internal structure, in this case it's the database scheme? Why do I have to change this just because I changed the internal structure? So my advice, if you are testing repositories and if it's possible, use the create methods of the API of your repository to set up the database content. So as a summary, treat your implementation as a black box. You shouldn't know from a test perspective what the implementation details of your module is, and only test the behavior. Your test should express the behavior of the module. Let's come to frameworks. Everybody uses frameworks because we don't want to code something which someone else already has implemented, right? So we're using JE microprofile, we're using Spring Boot, for example, and our code has to call the API of these frameworks, of course, make use of them. And what I see a lot, and that's the complaint I always hear, is we have to write a lot of framework mocking code. That's boring, annoying, and it's also sometimes very hard because sometimes there are final methods in the framework and you have to use PowerMock, which is very slow. So it seems that TDD doesn't work for these kind of applications where you have a lot of integration with a framework. So I have an example for this also. So this is it's a test for a JE microprofile application, and they're mocking the entity manager. This is a class responsible for saving and retrieving database records. And as you can see, they're doing a lot of stuff here. A lot about details how to use the API. I guess you have to implement this before you know how to do this test fixture. Yeah. But this is not the way you're doing TDD. You're writing the test first, and then you're writing the implementation. And also, if I look at the assertion, what does this test? It tests that I call an API. It does not test if the behavior of the module works as expected. I still can interpret or can have a wrong understanding of the API use, and the result, the behavior is wrong, but this test is still green because it's just testing, yes, I did call the API. So what can you do to avoid this? So my advice, write a wrapper. So a class which implements one of your interfaces, and this capsules the calls of the API. And then you can mock against this interface, your interface. You're mocking what you have under your control and what you know and understand. And this adapter can be tested in an integration test together with the framework, so that you make sure that the adapter is calling the API in a correct way. Another problem also has to do a lot with this framework code, and I often in the last couple of months I saw a lot of teams who have a fixed code coverage as a goal for their team. It's part of the contract with the customer, 80% or 85% test coverage. So they have to write tests which they believe does not help them to write the code, just to make SonarQube happy. Yeah. And an example for one of these tests is, can you see here? This is the class they would like to test. It's a REST controller in a Spring Boot application, and it has just one method, the price method, and this method calls the price calculation, the business logic, and returns the result from this business logic. So the unit test you write is quite simple. So you're mocking the price calculation, and you're testing that the object which you return by your mock is also returned by the price controller. This seems a little bit boring for me. So what you are not testing, and this is what this the main responsibility of this price controller is, you are not testing that from the outside this method is available under the expected path. and you're not testing that the deserialization works for the request. So if you're doing the request, this is a string, and your framework maps this on a list of JSON book ID objects. And so this is the magic of your framework, which you are configuring by this annotation. And this is something which you don't test if you're just writing a unit test. And also in the other direction, you're not testing the serialization of the price. So are there, is the JSON presentation of the price correct? So my advice at this point is don't write unit tests for I/O components. Use integration tests. You can do this very easily. For example, when you're using Spring Boot, there's a test framework for this mock MVC, and then you can use Rest Assured, for example, to send a request and to receive this request and test if the result is what you expect. And just forget the unit tests. Even if your integration tests are not accounted in your test coverage tool, it doesn't matter. Test coverage doesn't matter. It only matters, is it helpful, the test? Is it effectively, and is it efficient? So let's come to the last field of problems, acceptance testing. So what I read a lot in the last couple of months and years in internet blogs is statements like acceptance tests are the new unit tests. Yeah, you don't need unit tests, integration tests are the new unit tests. So the argumentation is quite simple. So they say unit tests, so the reason why you have unit tests and not integration tests is that integration tests are slow and unit tests are fast. But nowadays you have a lot of good application frameworks and test fixture frameworks, which makes your integration tests very fast. So I don't need unit tests anymore. I can just write integration tests or end-to-end tests. I don't need unit tests anymore. It's true that these tests are very, very fast compared to a couple of years ago. But this is not the only reason why you're using unit tests and not integration tests, and why you would like to have a lot of unit tests and just a few integration tests. So I would like to show you this with an example. So this is a Spring Boot application, a shop application, which manages orders in a shop system, and it on the left side it has a REST endpoint. On the right side it's a database where the orders are stored. And this application consists of 3 modules, classes, and there's a REST controller, of course. There's a class for the business logic, the order management class, and of course a repository class. Handling all the requests to the database. And together with the test utils from Spring, it's very easy and fast to set up tests like this as an end-to-end test. You can start just the application context and use an in-memory database. That's quite fast. And so you can write an end-to-end test, which is fast, so just using dbUnit, for example, to set up the data in the database, and Rest Assured to send the request and verify the responses. So why should you have unit tests? Seems easy this way. So let's have a look at one of the tests. So I would like to test that the delivery date, the estimated delivery date, is based on the delivery address and the created timestamp of an order. So my test fixture is that I'm inserting an order with a created date and a delivery zone representing the delivery address, and I expect I'm sending an HTTP request with rest assured in this case, with the order ID, and I'm expecting an estimated delivery time at 11 p.m. So this is what the business logic does. It takes the created time, it adds, takes the delivery zone and then calculates the estimated time. So what happens if this test gets red? If it doesn't work? Where is the problem? Where do I have to look? In which class do I have to look to see what I have done wrong? So when I just have this test as an end-to-end test, I have to look at the REST controller. There could be a problem with the time formatting, something like this, the serialization of the date, which I use internally. It could be a problem in the order management module. The time calculation could be wrong. Your pure business logic could have a problem. Or I could have a problem in my order repository on retrieving the created date from the database. Time zones and encoding are always problems which seems never to be resolved. Yeah. And what are you doing if you only have these tests? You're starting your debugger, right? So you're starting the application and start the debugger and look how the flow of the requests are in your application and try to see what's happening there. This is very time consuming. And this is the reason why you should not have only these integration tests. The scope of these tests is huge. To find the right place where you have to look, where you have to fix your problem, is quite large. So still have these unit tests, a lot of unit tests as a foundation of your test pyramid. And there's also another aspect why you shouldn't have only these integration tests. So what would you normally do if you're following the test pyramid? You would write tests for your business logic. Let's say 5 tests for this. You have 5 different test cases. And you would also write integration tests for the REST controller and for the order repository. Let's say these are also 5 tests. And then you would write 1 test to an end-to-end test, integration test, just to make sure that these components are wired together in a correct way. And so in totally you have 16 tests you would write. What would you do if you were just doing end-to-end tests? If you are doing end-to-end tests, means that you don't have an idea how the structure of your application is, what the modules are, and what the responsibilities of these modules are. So if you would really like to test all these things, all these test cases, you have to test all the permutations of the test cases. And I'm not I'm not very good with math, so I hope I did it right, but there are a lot of more tests you have to write. So if I'm correct, it's 5 times 5 times 5, so 125 tests. Even if there are some permutations which cannot occur, these are still quite a large number compared to what you have when you are following the test pyramid. And this is the reason why you shouldn't rely on end-to-end tests as the only tests you have. So follow the test pyramid, and tests should have a very specific scope that you can really see where you have to look in your code if a test is read. So why is it, so these are the problem areas. So why is it so hard to figure out how to do TDD, and why is it not so obvious that you have to handle these problem areas? A lot of developers think that a good QA is all about the test coverage. But this is not sufficient to have a good QA of your software. What you also have to keep in mind is that your tests are efficient, so this means maintainable. You don't have to rewrite your tests when you refactor your code, for example. And they have to be effective, which means they should test the behavior. And this has to also be to be considered if you're writing tests, not only the test coverage. The test coverage is easy to measure. Yeah? That's why we are all going for the test coverage. The other parts are quite hard to measure. There are tools for this. For example, the effectiveness can be tested by mutation tests. And efficiency could be measured if you look at your commits and if you see there are a lot of changes in your test code when you are changing your implementation. There are tools for this. There's a good book about this. I don't know the author. It's called Your Code as a Crime Scene, and there are some tools in this where you can make reports from your commit history and see if you have a problem with the maintainability of your tests. But it's quite hard to make sure that efficient and effective tests are the result of your test-driven development. So as a resume, my rules I would like to advise to have in your mind if you're doing your code reviews, and you should review your tests, of course, not only the implementation code, are develop your test against the module API. Don't have a one-to-one assignment between a test class and an implementation class. For me, this is an anti-pattern. Even if the frameworks guide you this way, don't follow this. It's the dark path. Test the behavior, not the implementation. Your test should reflect what is the expected behavior. And the name of your test should reflect the expected behavior, not this test that API XYZ is called. This is not a behavior. This is an implementation detail. Don't mock external libraries. Only mock things you own. So write adapters for your external libraries, test them in an integration test, and write a mock for your interface. And use integration tests for I/O components. So a REST controller should be tested in an integration test. A repository class should be tested against a database. Can be an in-memory database, but should be tested against a real database. And make use of the test pyramid. Even if there are blog articles who tell you not following the test pyramid, believe me, it's still valid and helpful. So, do you have any question about these problem areas? Okay, I think we have a little bit of time left, so I just would like to, yes, a moment. Okay, 5 minutes left. So just a quick, now I will go to, let's skip this. Okay, and we are just focusing on QA. This is it's just one aspect of TDD. What I would like to show you at the end now is what are, besides from these QA, are the benefits of TDD. Why should you doing TDD? And for me, it protects you from over-engineering. So you're just writing enough code to make the tests green. You're not writing any code for which you don't have any specification. Yeah? It's something developers always are trying to do, to write something which they could use in the future. This is waste. Yeah? Zero debug time. So if you have very specific small scoped tests, you don't need, or only needed sometimes, the debug time. Yeah? You know where the problem is. You have a test for a component, and if this test is red, you know this is where I have to look. No multitasking. So we have these 3 stages in the process, which are writing a test, writing the implementation code, and refactoring. And what we are doing is we are focusing on just one aspect of software development. When I'm writing the test, I'm focusing only on the specification, on the problem space of my software. I'm not thinking about the implementation, I'm not thinking about design, just thinking about what is the desired behavior, what is the specification, what is the problem I would like to solve. When I'm implementing, I'm just focusing on my APIs, on my technical stuff. I'm just trying to implement it, to make it work. This is the only thing I have in my mind when I'm doing this. And then in the refactoring phase, this is where I think about good design, maintainable design, readable design. And if you are not doing TDD, I guess you are trying to do all of these 3 things all together. And this is quite hard. And this is what TDD gives you. It gives you a framework for avoiding multitasking. It's a helpful tool for complexity partitioning. What does this mean? When I'm writing my tests, I try to write down tests with small implementation steps. So I'm decomposing my problem into smaller problem. And so TDD is a framework that helps me to decompose my problem and to understand my problem. I have no fear of change. So why are there in some project these God classes with 3,000 lines of code? Yeah? They all started just with 2 or 3 lines of code. And they get bigger, and there at some point you have to make a change in this as a developer and see, oh, I should refactor this. And then you see, oh, there are no tests. Oh, there's time pressure. So what are you doing? You are just adding another if-then clause, right? And so everybody thinks about things the same way. There's always time pressure, and if there are no tests, no refactoring, and then you end up with these God classes. So if I have these tests in place, I'm free to refactor, and I have no fear to change my design. And last but not least, if I write my test first, I have a testable design. If you ever tried to write a test in a legacy system, you know what this means. A design is not automatically testable, but when I write my test first, I only can write testable design. So these are, from my perspective, the reasons why I'm doing TDD, and I hope you will give it another try if you are not doing it yet. So thanks a lot for your attention, and if you have any questions, I'm glad to answer them.
Whose responsibility is TDD? Is it the whole organization, or is it just software developers?
So
QA should be a little more than just TDD.
So the question is, who is responsible for introducing TDD in implementing it? Yeah. So from my perspective, I am responsible as a developer. So I'm doing TDD to make my personal life easier. Of course, it's a lot easier if the whole team does it. And I'm always hoping that they will follow me. But to do TDD, we cannot wait for the management to introduce this. They don't know about this. They cannot understand this. They are not coders. They don't know what this means. I know what it means as a developer, and so, from my perspective, I'm responsible for this. So, I would quote Bob Martin, who said, if you're doing TDD in a correct way, then it is BDD. So this term is just introduced to emphasize that you are testing the behavior and not the implementation. For me, it's the same. Sometimes it's used for acceptance, for end-to-end testing, but for me, it's the same. If I'm testing software, I'm testing always behavior. Okay. So the question is, so what is the right approach to teach TDD, and is it focusing on, so where should you start and where should you focus on when you start with TDD? So for me, I'm not trying, so for example, the Conway's Law, I'm trying to focus on what is the smallest part of the problem I can solve. And I'm not thinking about the implementation, I'm always thinking about the problem when I'm writing a test. What is the smallest thing which I easily can implement right now? And my advice is start with a test list, not just start when you have heard the problem and just what is the first test which comes into my mind and then I'm coding this. This is what you're always doing in coding cutters. This is not the right way for me. I'm always taking, with my students, I'm always taking 10 minutes for each pair, and they're discussing the test cases, write them down, and bring them in an order, because the order is very, very important for the solution you're writing. So just take your time, just 10 minutes, understand the problem, and try to find the smallest parts, what are the test cases, and try to find a priority for them, starting with the easiest happy path test case. Okay. Ben, okay, one more. Quite hard to say, but I would say it's just the same amount of code for your test code like what you're writing in your implementation. Just about, sometimes a little bit more. It has to do how complex your business logic is and how many edge cases you have. But I would say around about the same amount. Can be a little bit less, a little bit more. Okay, then. Thank you again, and if you have any questions, you can come to me.